All right, so this is going to be the next topic that we're going to be covering in pre-algebra. It's going to be called Introduction to Rigid Transformations. Okay, this is going to be the standard that we're going to be dealing with. So let's start off by defining rigid. What does it mean to be rigid? Well, rigid is just something that is not flexible. Right, so you can't stretch it. Okay, you can't shrink it. Okay, or scale it. Okay, that means make it larger or make it smaller. So rigid means it maintains its shape. Okay, so the shape of the figure or the object doesn't change. Okay, so we're not changing the size. We're not changing the size. We're only going to be changing the position of the object. All right, that's all rigid's going to mean. Okay, so now we can define transformation. A transformation is just something changing, right? Transforming from one thing to another. It's some sort of movement. All right. The first type of rigid transformation we're going to be looking at is called a translation. All right. A translation is when you slide. Okay, and notice it's strictly slide. We're strictly only sliding. Okay, so that's what translation means. We're only sliding. Okay, an object left, right, up, or down, or any combination. Okay, so you can combine those. You can go left and down, right, up. Okay, you can mix them up, but we're only going to be sliding for translation. Okay, for the same distance. Okay, and we'll go over that. So let's look at an example. Okay, so let's look at this rectangle. This is rectangle A. All right, it has angles 1, 2, 3, 4. All right. So now what's going to be important for our class and what we're dealing with right now for this topic is to look at these key concepts and make sense of them. Okay, so real quick, look at this. You can look at this rectangle, right? And you could slide this around. You could slide to the right, then go down. You could slide left, go back up. You could slide down to the right. Okay, you could slide in whatever direction you want. Okay, just make sure for translation you're only sliding, and no matter which way you slide. Okay, what's important to notice is that lines are taken to lines. Okay, so what they mean by that is this. All right, so let's introduce the same rectangle, but I'm just calling it a different name. Okay, so the angles and the sides are the same length, but I'm calling this one A, and I'm going to call this one A prime. All right, so what I mean by that is this one is going to be the original figure. Okay, so let's call this one the original figure in the original position. Okay, original. We'll just call it the original. All right, and we can call this one maybe since we're translating, we'll call it the translated figure, and maybe we'll put it down here. Okay, so we'll call this one translated figure. Okay, and what we notice when we're translating, okay, so for example, to get to A prime, starting with the original, you would just slide to the right and then slide down, right on top. Okay, so notice that if we're dealing with the original figure and we're looking at the figure that got translated to the right then down, what's important to notice is that lines are taken to lines. All they mean by that is that this line gets taken to this line got taken to this line got taken to this line, and this bottom line right here got taken to this bottom line. Okay, it's a mapping. All right, that's all it means. And so back to the key concept, line segments are taken to line segments of the same length. Okay, so notice that when we translated this figure to the right and then down, the length of the lines didn't change, right? This length is still this length. Okay, that's what we're assuming. This length is still this length. This length is this length, and this bottom length is still this bottom length. All right. Okay, so that's pretty much the key concept for part A. Okay. For part B, it says angles are taken to angles of the same measure. All that means is that when you're translating a figure, okay, in this case, we're translating the rectangle A. We're moving it around. In this case, we moved it here and then moved it down. Okay, and when we did that, the angles didn't change, right? We stayed with 90-degree or right angles the entire time. Okay, so we're not changing the angles. We didn't change the length of the lines. We only changed its position, right? That's what we set up here. Okay, and that's going to cover part B. So part B is just saying that angles are taken to angles of the same measure. That just means the angles don't change when you're translating. Okay, so maybe we'll put it up here. Angles, we'll say angle size. Angle size doesn't change when translating. Okay, that's all it means. It just means that the angle measure stays the same. All right. And the last one, part C, says parallel lines are taken to parallel lines. Well, what does that mean? Well, if you look at these two lines right here, these two lines are parallel right here. And when we translated this figure to the right then down, these two lines were still parallel. Okay, so all that means is parallel lines are preserved. Okay, so if you start with parallel lines and you translate, you're going to end up with parallel lines again. Okay, and the same thing goes for these top two right here, right? These top two are parallel, and when we translated this figure to the right and down, we got another pair of parallel lines. That's all it means. It's very straightforward right now what we're doing. We're just realizing that lines are taken to lines, so line segments are taken to the line segments. The length of the lines don't change. The measures of the angles don't change when you're translating. And parallel lines stay parallel lines when you're translating. All right, so that's going to be it for this this short video on translations. Okay, for the first type of rigid transformations. In the upcoming videos, we're going to look at some more types of rigid transformations. Okay, thanks guys. See you in the next video.